Okay, so yes, I am an attorney, patents, and so since I've been here, I've been asked maybe a dozen times, can you patent something, right? Can you patent software? Can you patent an algorithm? And so my answer is, you're asking the wrong question. The question is, are you solving a problem? Are you solving a real life problem that people care about? And you have a solution to it, right? You have software, or you have software on a computer, something like that. Is it solving a people problem? If that is the case, that is the kind of thing you patent. That's why patents are around. That's why they're there. All right, so just leave you with that. If you'd like to talk more, I'd be happy to do so. And of course, I know there's other patent attorneys out here, so just reach out, talk to one of my peers. I'm sure they can help you answer that question as well. All right, so the topic here is hot topics in AI. We're going to be talking about blockchain. We're going to be talking about data privacy and security, as well as VR, AR, and IoT sensors and things like that. So I'm kind of excited to talk here because the whole blockchain issue in cybersecurity is really big, and we know it's such an important component and an influence on where AI will eventually go. There is a regulation that's coming out that's really big, and it's really going to affect this field a lot, I believe. And it's a regulation that's coming out in Europe, May 2018. It's called the GDPR, General Data Protection Regulation. And it is widely regarded as the most expansive regulation protecting privacy, rights to data, how data is used, permission to use data. And I'm going to there's a particular quote here, and I'm going to quote right from the regulation. And when I do, I think you'll see why this is pretty significant, something worth mentioning in this type of setting. So the person who owns your data, the data controller, and this is straight from the regs here, shall implement suitable measures to safeguard the data and respect subjects' rights, to obtain human intervention on the part of the controller, to express his or her point of view, and to contest the decision. A machine is making a decision about you. In particular, the controller must allow individuals to express their point of view, to obtain further information about the decision that has been reached on the basis of this automated processing, and the right to contest this decision. Well, I think we know how this is relevant to this discussion. If you're using personal data, first you have to get permission to do it. We know that, okay? But also, if that's reaching a decision, that person has a right to understand and know how that automated processing reached that decision. So if you're talking about a loan application, you're talking about getting health insurance, but I can envision it going a little further, a diagnosis decision that relies on a machine to augment a decision, perhaps. You need to explain that. Well, we know with the rule-based system, expert systems, you can figure that out, right? It's all there. But with deep learning, how did it reach a decision? You gave it experiences to train on, it gets a new experience, and it outputs something new. How did it do that? Explainability. I think this type of regulation is going to really drive more the discussion that's going on now, as I'm sure everybody's heard, on to the transparency, accountability, responsibility for deep learning AI algorithms, this type of regulation. This also ties into this concept of data asymmetry. I don't know if you've heard of that, but data asymmetry is referring to the fact that today, organizations treat your data as much more of an asset. It's a much more of an asset to them than it is to you. It's your data. You should have a right to make use of it, but organizations make more of it. I think what you're also going to see in the future, I'm making predictions here, is that organizations would heed the advice, and I think the GDPR is a step in this direction to involve the person. There is an intention on the part of the person who owns the data to develop this profile, as opposed to going out, scraping the web, and putting together a profile of you. You may not even know it's happening, or certainly have permission for it to be put together. So those are a couple topics. I'm going to stop now, give more time to my distinguished guests, and I'm going to turn it over now to Kevin.
Wonderful, thank you. Good afternoon, everyone. It's a pleasure to get to speak to each of you today. This talk is about blockchains. It comes in two parts. The first, which is now, I'll go over some of the concepts of blockchains and how they apply to medicine. And then in the next part, which is here at 2, I'll show how I made a very simple health application that stores biometric data on a blockchain. So I think we all hailed the time when the internet showed to us that content can be created and distributed with no cost. And the internet has been a remarkable source for democratization around the world, giving voice to those that have none and really elevating them to a global table. That comes with a cost, though, and the cost is that when you're able to create information with no cost and distribute that, we're able to manipulate information, and sometimes information is invented, and we've seen recent examples of this. This is one such recent example. Two young men in London recently created a website for a fake invite-only restaurant. They put on this website fancy pictures of food, which were really things like shaving cream and tablets. They, through this website, created enough real interest and fascination that they had people walking back and forth their small streets, and they ultimately were able to become the #1 rated restaurant on TripAdvisor in London, despite never having served anyone anything. That is the first of more than 18,000 restaurants in London. So we have a problem with trust today. We no longer work in a small community that self-polices. We're asked to exchange data and speak with people around the world, some of whom we don't know and some of whom we may not immediately trust. We have other problems in medicine. We, as our own healthcare consumers, do not effectively own or control our own healthcare data. Do you trust that those who do control it act with your best interest and only your best interest at heart? To give you an example, I am a pediatric cardiologist. I work at a medical center. Up until recently, there was a community pediatric cardiologist who decided one day to pick up and get out of medicine. I have, in the last 3 months, had as many families come to me saying that they were unable to get years of data out of this practice after it had closed. One family contacted the doctor on LinkedIn, and he said that he'd send them the information, and he never did. So these families lost, if not never controlled, access to their own health care. Now, in the West, we've come to accept the separation of church and state because history has shown us that bad things can happen when those things are combined. And I think we need to start thinking about separation of a health delivery industry from our own medical data. Even so, we're the privileged ones. We are not the average healthcare consumer. Who is the average healthcare consumer? The average healthcare consumer is a 24-year-old Han Chinese male that lives within 800 miles of the most populous part of the planet. He doesn't have most optimal access to healthcare and health data exchange. And what happens to these 6 billion people? Distributed data is really the answer to an open, borderless, and completely global health data exchange. And blockchains serve to answer that distribution of power. So this is the obligatory Bitcoin slide. In 2008, a white paper was published that birthed the first decentralized currency, at least the first that worked. It combined a peer-to-peer communication network called the Bitcoin Protocol with a way to reach distributed consensus among parties, and ultimately added that to a public transaction ledger called a blockchain. The key point here is that this technology enabled two groups to reach consensus without any intermediary third party. Two people that might not know each other, that might not trust each other, are able to reach consensus on something without an intervening bank, without an intervening hospital, or any third party, and that's a very big deal. Blockchains are ultimately based on a data structure called Merkle trees. Basically, data is added to the structure and it's mathematically fingerprinted based on data that's come prior to that. So these blockchains ultimately are sources of data truth. There are key benefits over traditional data stores. I'm going to draw your attention first to the Paul Baran document at the bottom. I don't know about your hospital, but at mine, our EHR is very much a centralized system. And the moment that EHR goes down, every other computer in the hospital becomes effectively useless for patient care. Decentralized management with blockchains allow peer-to-peer nodes to act independently but follow close protocols. Data that's available and robust means that medical records are preserved and continuously available. There is also clear data provenance. There's no administrator that can go and effectively own the data. That data is owned by the owner and able to be shared by the owner based on cryptographic protocols. Data is also immutable and protected by, is secure and private based on cryptography. One of the more fascinating things about the world we're in today is that innovation is not only happening at our centers, but it's happening on the periphery. And some of you may remember a very similar thing that happened in 2007 in Kenya called M-Pesa. And that allowed Kenyans to pay each other with their mobile phones, bypassing the banking system. And it really fundamentally changed the way that Kenyans interacted at that time. So how does such innovation and such distribution and access of worldwide healthcare and worldwide health delivery change? Well, does it enable true population-based outcomes measures? Blockchains at the moment don't scale as well as traditional transaction ledgers, but that's changing, and that's changing exponentially. What happens at some point when we're able to achieve 10 or 100 transactions with our database every millisecond? Well, it changes healthcare from a batch medium to a streaming medium. We've seen how streaming has changed the way that we create and consume music and movies. And the question is, how does such a change, how does such an increase in scaling change healthcare? Well, when we get data that quickly, it allows us to have software agents, real-time monitoring, and ad hoc agreements. Imagine, for example, someone that goes into a relatively high-risk procedure, such as a surgery. If it doesn't take any extra effort to do this on a second-to-second basis, imagine insurance companies that risk adjust and change premiums second to second based on the surgery you go in, potentially variables that change in real time, and then ultimately your premiums and risk assessment return towards normal as you exit that surgery. This drastically changes the way that we think about healthcare delivery. Confidentiality and transparency are obviously of paramount importance with blockchains. That's something that we'll talk about and I'll show a little bit later on. But blockchains are out there at the moment in the real world. On December 5th, the BBC published a very interesting article documenting that in 2008, 300,000 infants in China had become ill because they had taken formula that had been counterfeit and had been seeded with melamine to hide protein content from government regulators. A company came out that protected the seals of those devices with instruments backed by a blockchain. And so parents like the one in the picture are able to use their phones and check the provenance of that formula and make sure that it passed through trusted hands at all times. That's fundamentally changing something at the ground level. Ethereum is the second most well-known cryptocurrency out there. It's the second biggest after Bitcoin, and it's caused a lot of excitement because it adds advanced features that aren't available in the original Bitcoin protocol. One of those is smart contracts. Smart contracts are computer programs that you can write and then you can distribute onto the blockchain. When they're on the blockchain, they're verified and they're run out there independently on all the nodes. And so normally when we think of blockchains, much of the data on the blockchain is traditionally open. That, of course, becomes a problem in certain circumstances. We can encrypt all our data, right? So we can encrypt the data on the blockchain, but that becomes a problem when we're dealing with emergencies. What about a smart contract like this? A smart contract where a healthcare provider who's verified to be working nearby can use a function or a smart contract and use her private key to allow access to the medical data of an unconscious patient. These are some of the ways that we're trying to deal with the issues of confidentiality at the same time that we can be transparent when needed. So blockchains are immutable ledgers of trust. They have the potential to really radically change healthcare. And I'll show an example of how we've done that too. So thank you. Hello?
No, sorry. I don't need that. This? Yeah. How do I change? Hi, my name is Mohit Mehra. I am a data engineer at Children's Hospital of Los Angeles, and I work for a department within Children's Hospital called the VPQ. I actually work for Dr. Wetzel, so he's a great mentor, and thanks Dr. Chang also for inviting me here. And today I'm here to talk about sensors and IoT in biomedicine, specifically applied to the ICU. So yeah, this is by now an old picture. Since the last 2 or 3 days, people have seen this. But essentially, the important thing here is this little child. And I think to me, as a data engineer, collection of data from these devices is of utmost importance. And that's what we work on. This is basically a picture that shows there's like hundreds of companies right now doing AI-based software or big data, and it's just growing to this very large set of companies. And then we have, but all of these companies are really focused on still ads and customer analytics. I guess the question that we ask is, where is pediatric healthcare in all of this? And the people here obviously would appreciate that pediatric healthcare should somehow, someday come at the top of this bubble chart. So yeah, before we get to the IoTs, there's a brief history of IoTs in the ICU. Essentially what we call medical devices that are connected to the network. Now we've started calling them IoTs, but they are capable of transmitting data at very high samples per second, 60 or 100 samples per second. So we started out with some of the monitoring devices from Philips and GE, and then eventually we started getting data across the network using HL7. In the 2000s, we start seeing the formation of much larger databases, essentially clinical information systems from Philips and GE. But then eventually, starting the 2008s onwards, we start seeing EHR, which now collects high quality, relatively high quality EHR data, basically healthcare data. So what are the challenges of handling streaming data from these IoT devices? I mean, the biggest that we obviously look at is the interoperability. There are so many vendors in that picture that you saw in the ICU, each with different sensors, and so they speak different protocols, essentially not speak the same language. There's obviously the big question of liability, which Kevin really touched base, and obviously if the future is blockchain, then I'm all for it. But before then, we still have to address hospitals' needs of this protectionist culture, they don't want to share data, but as researchers, we want more data. And again, a lot of hospital infrastructures still cannot manage and handle the velocity and the volume of the big data. And there are some machines that are generating essentially petabytes of information, which right now gets pretty much thrown away at many different hospitals. So yeah, storage is a concern. And last but not the least, skills. So we need to hire more people who understand big data technologies, AI, and data science. So we at VPQ Data Engineering, we basically, that's what our goal is, to try and address those challenges using some of the more industry known companies such as AWS. We rely heavily on Amazon, Apache Software Foundation for all of our open source needs. And at the middle of all of this is Hadoop. Basically, we thought before starting on a Hadoop journey that the data was so siloed that we need to bring the data together. And so it is truly a distributed data repository. And as Kevin touched base that, there's obviously security concerns when you throw data together, such large amount of data in one place. Well, Hadoop, at some point, at least from a storage and computation point of view, addresses that, that problem of distributing the data. And even, so like we started with just 3-node cluster as compared to, at the moment, Yahoo is running 40,000 node cluster just to do social media analytics. So I think there's obviously a lot of opportunity to grow and come up with better distributed solutions. So at this time, this is our infrastructure that we felt was necessary to provide or address all the challenges and use cases. So at Children's Hospital, we basically built pipelines that take batch data from the monitors. We got EHR data, you know. I think Cerner has 2,000 table database, which is massive. Labs data, medications, intubation, ventilation. So these are all very specific systems storing their application-specific data in their own repositories. So how do we keep that up to date in our own distributed world? We had to tap into these data sources. Also, the streaming data is, I guess the talk here is about streaming data. So that's essentially very important at some point later in time, because once you have your models, once you know that you have a high degree of confidence predicting something, well, how do you plug that back into the bedside? And so therefore, it's essential to understand the challenges and of streaming data itself. So so yeah, I'm just going to go fast. So yeah, for streaming data, we use what's called Apache NiFi, which is essentially, it came out of the NSA. It was called Niagara Files, I believe. But it was created to address taking data from a lot of sensors across the world. So we use that and it helps us with a lot of things like reliability of data. Did the data get lost in transit? What happens if your downstream system gets backed up? So where do you store that data? So it's essentially handling of that deluge of data. You need some technologies in middle, at least as of now, before AI completely takes over, to try and mitigate those risks. So let's see. Yeah, I think I wanted to also touch base on Spark. So like once you have the data, like how do you give the data to a data scientist? Like, you know, usually data scientists love to see the data in a nice format. They would like to see a time series, sparse matrix data where everything is converted to numerics. So we could potentially do all this work in the data pipeline as long as there are certain rules established, which obviously is debatable what the rules are, but at least we can create a data pipeline that allows us to do the cleansing, the munging of data, aggregation, and ultimately it's important to do de-identification and anonymization of that data. So before you give it out to anybody running their machine learning algorithms. So this is just an example of what the data might look like when it all gets aggregated. We do get multimodal data, and it's really hard to actually put that all together in a time series, in a clean time series format. And so that some of the work that we're doing with Spark is actually giving us really good results with that. Okay. And yeah, one important thing is cloud, because we found that hospitals obviously is reluctant to do anything in the cloud at the moment. Hospitals, in fact, not just one, because of security reasons. But it's our goal and aim to hopefully work with other children's hospitals to get to receive their data and actually collaborate with them, and so that we can run machine learning algorithms in the cloud. And the beauty about the cloud is that you can provision the hardware really fast. So I think Amazon plays a really good role in that. In fact, this is an example of what we have done with the data. We went through very rigorous procedure of de-identifying and anonymizing the data, removing everything that's text, so everything is like numeric, and then we pushed it up to a secure encrypted connection onto our S3 buckets, and then eventually how the data flows through within the cloud infrastructure. And that's just a very useful way of streaming the data into a data pipeline and eventually making the data available for machine learning. And yeah, this is my last slide. Basically, it's just emphasizing on the more data, the better it is. So this is just an example of running. I think this was run on a pediatric early warning system using RNN, and it just goes to show that as we increase the percentage of the training data, our AOC curves just started getting better. So not only do we need more data, we actually need more diverse data, and we need more depth in the data. And the way I feel this can all take place is when multiple institutions collaborate. And that's it. Thank you.
Is this on? It is. Ooh. Cool. I'm Sam Warner, CEO and founder of Well Told Entertainment, and I'm also a 25-year-old mild hypochondriac who spent lunch listening to AI predicting mortality rates in people like myself. So, excuse me if I'm going a little fast. Okay. So, Well Told Entertainment is actually, we do a lot of game development and primarily in the AR and VR space. So if you don't know what AR is, we like to describe it as bringing the digital world into our own by tracking 3D content onto normal camera footage. So here you can just see a simple game of chess being played, overlaid on a normal iPhone's camera footage. And so what I'm going to talk to you guys about is probably a little bit less on the medical side and more on a post-production, post-mortem side for doing custom app creation in AR as it pertains to medical information. And so we built this app for Bioness, which is a medical hardware company, and the goal was to educate people about the effectiveness of their hardware. While using augmented reality to give patients, doctors, and marketing agents the agency to explore and demonstrate different parts of this process. Okay, so onto the app production. We used Unity Engine, which I'm sure some of you have encountered before, to do most of the 3D rendering. And also used Vuforia, which is a pretty common AR library for tracking. Since then, we've moved into using Apple's AR Kit, which is another really awesome solution for trackerless tracking, AR tracking, that is. We had to reconstruct all of the 3D assets using their really high-resolution CAD files. That was primarily just so it would run on a mobile device, but also we need to make sure that it would look good up close and personal with AR, because a big part of that medium is putting the control of the camera into the hands of the user. So that meant that a doctor would be able to hand a client an iPad or an iPhone, and they'd be able to explore on their own, which again gives them some agency over the learning process. So at Well Told Entertainment, we like to think that we do some amount of storytelling, and we want to bring that also into any of the medical work that we're doing. And so being able to effectively tell the story of what a patient is about to go through or be a part of, that was something that we wanted to bring to the table. And so we settled on this process finally in AR, which is kind of like it's like a video that loops, but it's with a whole slew of complicated 3D assets and shaders and animations that step you through this process of someone applying the stimulators, affecting their gait, showing all of the nerves and bones and muscles in the leg and how they stimulate. And so instead of going for a really overly complicated interface that would let someone step through every single moment of the procedure, we opted to kind of let it play out in front of them so that they could watch it a few times and get comfortable with the process. Okay, so then we did have a few mild roadblocks. We wanted to make sure that we had medically accurate assets, not just from like a 3D perspective, but also all of the animation that the characters do needed to be medically accurate from the gait down to the way that the foot moves when it's stimulated. The custom shaders that we built needed to effectively articulate all of the process within the procedure. And so building those took lots of time, and it definitely made it more difficult to run on a device the more complicated these shaders got. And in our communication with doctors, as we're kind of an entertainment company, and they are, of course, more familiar with the medical process, we needed to make sure that we were balancing the medical accuracy and the ability for any device down to an iPhone 4 to run this. And so this is really all just to say that developing custom apps to illustrate medical procedures it's a lot of work, and it's also an incredibly important thing to get right. We had a lot of back and forth with users saying that they wouldn't understand something, but that it was more medically accurate, and so we were going back and forth on that for many weeks. So the learning lessons to take away here is that AR is a really great tool for education and marketing because it puts the power into the hands of the user for how they experience this kind of education. You can, yes, make a traditional video or a PowerPoint slide that's thrown together with a bunch of GIFs, but AR really lets someone dive in and experience what they're seeing kind of in a hands-on capacity. It's definitely still impressive. This is something that Bioness was using at trade shows kind of all around the country. And as a centerpiece in most of their shows, it repeatedly got more and more clients to their booth than their competitors. Simple experiences in AR are still really, really important and really good. Going overboard with lots of complicated in-scene 3D buttons and too much information on the screen actually takes away from the unfamiliarity and the learning required to experience AR, because most consumers have yet to actually try this. And then optimization is very important, of course, in order to run on all mobile devices to get it into people's hands. And then also visual storytelling in AR makes a complex product easy to see in action. And so that's the biggest takeaway for us, is that we have made medical videos before, but because AR allows for a certain amount of interactivity, it was a great tool for anybody that had no idea what the medical procedure was going to look like to kind of get their hands dirty and really come to terms with what that looked like. Cool. So if you have any questions, or if you'd like to talk more about making custom apps for in AR or VR, just let me know. Thanks a lot.
Okay, well, that was very interesting, and very different aspects, but all kind of related to the same topic. I wanted to throw out just a couple of questions before we get to everything else. Kevin, you mentioned in your Bitcoin discussion that being access to the information in security, in emergencies, would be hindered by the kind of encryption, the protection. How do you see that working itself out? Because my understanding of Bitcoin, one of the advantages, and certainly there's a debate on this, I'm not saying it's a concluded question already, is that Bitcoin can greatly enhance security of data. And we all know that's important in this context.
Yes, so I think that's one of the areas where things like these smart contracts can help. We can encrypt by default this information that we store on these blockchains. But we need a way that in cases where we need to access it, such as with an unconscious patient, we can. And that's something like what these smart contracts can do. So you can mathematically verify that you have a physician that's in the local area, that is licensed and working, and that smart contract, if programmed correctly, may allow someone to be able to prove to themselves that they are an entity that needs to access this, and therefore, in those cases, may be able to access it. Clearly, this, though, is an area of very active research, and I think in terms of blockchains, we're still very much in the infrastructure stage as opposed to the app development stage. So we're very young here.
Great. And Mohit, I had a question for you. I'll just keep it brief here. So there was a very interesting point brought up yesterday about when you have a device and it needs to go through the FDA, the regulatory process, especially if it's using online learning, it just seems like such a big roadblock or obstacle to getting something approved. And so in the envision, when using this data in automation or augmenting decisions, do you see any way about how, I mean, it seems to me that there's a lot of great ideas that never go anywhere because they're just so intimidated by the approval process with the FDA. You have any thoughts, especially for kind of like an online learning system like you were talking about?
Yeah, I think I can only speak for ICUs at the moment because it's very I believe it's really complicated to create one device that actually takes a decision, because if you think of a critical care physician, they're taking inputs from several such small devices and then they make a decision on top of it. So you might look at the monitor data for heart rate, you might have to order in a blood gas, then you may get an X-ray for something, and then you make your decision. So is there a device that actually can sit inside the ICU and do all that? I don't see it right now happening.
Oh, okay.
So we need to create, again, in the AI world, we're still working on, we're baby steps, so we're creating the brain and not everything else. So that's my answer. So.
Interesting. Okay, so I guess we can go to Kevin. Do you want to say anything?
There's I think a few questions there that I think are very good. First, as in full disclosure, I do not own Bitcoin, as was asked. I wish I did. In terms of incentivization for miners, that is something that is also very actively debated. There's other things besides proof of work, which is very energy intensive because it requires mathematical code to be run continuously. There's proof of stake. There's various other types of proof. There's people working on Byzantine consensus, which is a whole other thing that's very mathematically intensive. So there's ways to incentivize that. In terms of cost for storage, also an unanswered question. Currently, if you were to store, as of about a week ago, a page of text on the Ethereum blockchain, it would cost you between $10 and $15. A chest X-ray of good quality would be about $30,000. So that's not something that you would obviously today store on the main blockchain. That doesn't mean that you can't run your own private blockchains, though. And in those cases, even with things like Ethereum, you can have your own private blockchain that is within your organization and does answer some of these limitations. So there are other ways to approach this. But those are great questions that I don't think are fully answered yet.
I have a question here for Sam. Is the AR done through QR code interface? I'm not sure. I don't understand the full question, but...
Yes, it is. And that app that we built was done with Vuforia, which is a QR code interface. But the stuff that I mentioned right after that, Apple's ARKit actually uses SLAM information, which is the next step beyond kind of a QR foundation. Yeah.
Okay. Well, we're at 0.0, and Anthony's got to move things along. Let's thank everyone for talking. I think they did a super job.